An important idea in mathematics, and the central idea of calculus, is the idea of a limit. The idea of a limit is this. Suppose we have a function that depends on a variable, and the value of that variable is approaching a certain number. In this case, we imagine that the variable x is getting closer and closer to 0. What does that mean about the output values of this function? Are they approaching some quantity? Well, we could answer this question by plugging in values of x that are closer and closer to 0 to look for a pattern. This table illustrates that idea. So we start by plugging in 0.1 for x, and we evaluate the function there, and we see a certain output of approximately 2.5893. As we plug in values that get closer to 0, we get outputs that appear to be getting closer and closer to 2.3. Okay, but notice we've only plugged in values that are getting closer to 0 and that happen to always be greater than 0. We could also ask what happens if we plug in values that are less than 0 and getting closer to 0. That's what this table shows. Now we're plugging in values that are getting closer to 0, but they're slightly less. And instead of getting values for the output that are close to 2.3, this time we get values that are close to negative 2.3. So we have some notation to illustrate the results that we've observed here. The first notation expresses what we see on the left table, that as x gets closer and closer to 0, but only from the right side, and we indicate that with this little plus sign as a superscript. As x gets closer to 0 from the right, this quantity's outputs get closer and closer to 2.3. On the other hand, as x gets closer and closer to 0 from the left, which we illustrate with this notation, meaning we're plugging in values that are close to 0 and on the left side of 0, the output values get closer and closer to negative 2.3. Now, if these two quantities had been the same, we would just say that the limit is 2.3, or if they were both negative 2.3, we would say the limit is negative 2.3. But because they're different, this function actually does not have a general limit as x approaches 0. And we'd have to say that the limit as x approaches 0 does not exist. Notice the difference here. This time there's no superscript saying that we're approaching from the left or from the right. This notation would mean that we're only approaching from both sides, and we're only saying that there is a limit if the limit on both sides is the same. Because that's not the case, the limit of this function does not exist at 0. We could also see this behavior by looking at a graph of the function. This is a graph of the function 10 to the x minus 1 all divided by absolute value of x. Notice that as we plug in values that get closer to 0 but are positive, the output values approach a little bit more than 2. That's consistent with what we saw in the tables on the previous screen. Whereas if we plug in negative values that are getting closer and closer to 0, the output values are approaching a different quantity. So here we're seeing the limit from the right side. Here we're seeing the limit from the left side. And because they're not the same, the limit does not exist.